Welcome to Lesson 2, where we'll look at graphing. Here we'll look at graphing when we're given a table of values. Since we're going to be graphing, graph paper will be needed through this section and throughout the unit. So let's start with example 1. The table of values below represents the amount of money made from selling cookies at a bake sale. So if you sold 1 cookie, you'd make $1.25, 2 cookies, you make $2.50, and so on. Part A wants us to identify the independent and dependent variables. And when we looked at this previously, we said that when the independent variable changes, the dependent variable is going to be changed as well. So one affects the other. So in this example where we have the number of cookies sold and the amount of money, the number of cookies sold affects how much money is made. So we can say that the independent is the number of cookies sold, and the dependent is the amount of money made. So this makes sense since the amount of money depends on the number of cookies sold. Now if we got to take this information and put on a graph, we need to remember that the x-axis corresponds to the independent variable, which was the number of cookies sold. And the y-axis corresponds to the dependent, which was the amount of money given in dollars. Now looking at the table, we have to plot 1, 1.25. 1 cookie was $1.25. Now the scale on the y-axis here is in increments of 50 cents. So $1.25 would be around here. Then 2 and $2.50, 3 and $3.75, and 4 and $5. So there's the graph. Next part, we're asked to determine if the data is discrete or continuous. And you notice that I did not join up the points in the graph because this data is discrete. And it's discrete because we're not going to be selling 2.65 cookies, for example. Because we're not going to have an infinite number of values between 1 and 2, for example, then we call it discrete. So we're going to say it's discrete as the number of cookies sold will not be 2.65, for example. So we'll leave the graph as is. Now the last question wants to determine if it's linear. And looking at the graph, it looks linear, but they want us to explain using the table. So just to quickly write down the table here again. 1, 2, 3, 4. 125, 250, 375, and 5. I see that this is indeed linear because all the independent values increase by 1, and all of the dependent values increase by 1.25. And that's what makes this linear. So we can write down that this is linear since there is a constant change in both the independent and dependent variables.